Okay, second part of the core activity. In this one, we're going to go back to the equation that you saw in the opener, which was x plus 2 equals x plus 5. And as you thought about this, you probably realized that there was no x value that could make this work out. So you probably realized that there was no solution. It was impossible to find something like this. And so here's an algebraic tile representation of this equation. We're going to use this to try to figure out why there's no solution to this, and hopefully it gives you a good visual. So let's hop over here. I wrote it down for you guys. Here's x plus 2 side. There's the x with 2 tiles, and then here's the x with 5 tiles. And so to start solving these, we would try to combine like terms and pair these up. So here's the first step. Let's introduce a negative x so that these will cancel. And I'll bring that over here, combine it with this one, and these will cancel. So I'm left with 2 equals 5. Well, think about that for a second. Does 2 really equal 5? Of course not. That doesn't make sense. But we could take this a step further, and we could introduce some negatives so that we can cancel out these guys over here. And now that's all gone. So what am I left with? Well, there's nothing left on this side, so the only thing left over here is a 0. And how many are left over here? 1, 2, 3. So this is saying that 0 equals 3. And we cannot simplify anymore. Everything that can be canceled out is already gone. Okay, those are opposites, and they're gone. And so all we have is 3 on this side, nothing on the other side, so that's a 0. And is this true? Does 0 equal 3? Well, of course not. And so this is also false, which means that there's no real solution to this problem or this equation. There's no number that we can put in the x value that will give us the same result, or that'll make them equal to each other. Now, if you really think about this, think of any number that represents x, and if you plug that number in here, you're applying two different operations to that number, so there's no way they're going to end up being the same. On this side, you're adding 2 to that number, and on this side, you're adding 5 to that same number. And so that's never going to make them equal because you're doing two different operations on them, and this just proves to you that since 0 does not equal 3, there's really no real solution. So when you get something like this, where you get a statement that is not true, this means that there is no solution. Okay? In the previous problem, for the first part in the core activity, you noticed that there was one solution, and that was x equals 2. But in this example, we just got a statement that is not true, and that's always going to imply that there is no solution. Okay? So hopefully that helps you, give you an idea, a good visual with the algebra tiles. And once again, I will explain this a little bit further with graphing and algebraic properties later in this lesson. So I'll see you guys in the next video.